Hello everyone, welcome to AP Calculus. So let's solve this beautiful question on the convergence and divergence of the integral. So it says that two integrals are given to us and both diverges when p is equal to what? So for what value of p they both diverges. So let's look at the detailed solution of this. Both of them are improper integral. Why they are improper integral? Because you can see here the upper limit is infinity, due to that it is improper. And in this case the x cannot be 0 and we are starting from 0 over here, so due to this lower limit as 0, this is the improper integral. So let's solve this thing. How to solve the improper integral? So first one, I am solving for the first one first. So 1 upon x power p, if I am going to integrate like this, so integration will be, if you take it like this, x to the power of minus p dx, and it is 1 to infinity, and we can say this will become x to the power of minus p plus 1, minus p plus 1, so basically 1 minus p upon 1 minus p, and the limit is going from 1 to infinity. Now when we put infinity over here, that's what we have to calculate. Directly we cannot put infinity, we are going to take the limit over here and we can directly put the 1, and there is no issue in putting the 1, but for the infinity we have to check. Now there can be two cases, when the p is not equal to 1 and when the p is equal to 1. So I am taking case 1, when the p is not equal to 1. If the p is not equal to 1, then in this case either it is greater than 1 or either it is less than 1. So if I am saying if p is greater than 1, if p is greater than 1, so we are looking for minus p plus 1. So if you take this p on the right hand side, so we can say minus p plus 1 is less than 0, negative. So what will happen due to this? So x to the power of negative number we are having, and we are applying limit x goes toward infinity. So x to the power of negative means 1 upon x it will become, now it will be positive, and limit x goes towards infinity. So when the x is going toward infinity, our denominator is getting a very large number, so 1 upon very large number, it will approach towards 0. So this is converging. So we can say it converges when the p is greater than 1. In the same case, if you look for p less than 1, let's say if p is less than 1, so minus p plus 1 is greater than 0. So minus p plus 1 is greater than 0, so it means x to the power of positive and limit x goes toward infinity. So x power is positive and x goes toward infinity, so answer is infinity. So it diverges. So p less than 1 it is diverging, p greater than 1 it converging. So let's see the second case, case 2, when the p is equal to 1. When the p is equal to 1, so we cannot integrate like this. In this case the question will become 1 to the power infinity 1 upon x. So 1 upon x integration is ln of mod x, and we are applying the limit from 1 to infinity. So here we directly we cannot put the infinity over here. How to solve it? We can say, let's say the upper limit we can take it as b, so or we can convert it like this, ln of mod x 1 to b, and the b goes toward infinity, so we'll say ln of b mod b minus ln of 1, and we are applying the limit b goes toward infinity. Now ln of 1 is 0, so when the b goes toward infinity, ln of infinity is also infinity, so we can say diverges. Therefore result is we are getting for p this thing, for p greater than 1 it is converging, for p greater than 1 this converges, and for p less than or equal to 1 it diverges. This is the result for the first question. Now let's look at the second one. It is again an improper integral, 1 upon x power p, and 0 to 1 is the limit. So second one now. So we can say 0 to 1 is the integration and 1 upon x power p. Again I am taking the two cases. Case 1, when the p is not equal to 1. When the p is not equal to 1, either it is greater or smaller. So or let's do the integration also. So p or integration will be like this, again the same thing, x to the power of minus p plus 1 upon minus p plus 1, and the limit is going from 0 to 1. Due to the 0 it is an improper integral. So case 1, when the p is not equal to 1, it means I am taking when the p is, let's say, less than 1. if the p is less than 1, so in this case minus p plus 1 is greater than 0. So minus p plus 1 is greater than 0, so x to the power of minus p plus 1 is greater than 0 means positive, so x to the power of positive number, and when we apply the limit x goes towards 0, right? When x is going towards 0, so it is becomes 0, so due to this it means x is become 0, so it is converging, so we can say it converges. On putting the limit as 1 there is no issue, only issue will be there on putting x as 0. Second thing, when we say p is this was less than 1, so let's say p greater than 1. When the p greater than 1 is there, so minus p plus 1 will be less than 0, so x to the power of negative, right? X to the power of negative it will be, and limit x is going towards 0. When x to the power of negative is there, so it means it can written as 1 upon x to the power something positive, and limit x goes towards 0. Now what will happen in this case? The x is going towards 0, denominator is getting smaller, so 1 upon a very small number it will approach towards infinity, so we can say this will diverge. So on putting the 1 there is no issue, on putting the 0 we are only checking for the 0. Now case 2, when the p is equal to 1, so when the p is equal to 1, the integration we will do as ln of mod x, and the limit is going from 0 to 1, right? So in this case again, how we are going to solve it? It is ln of 1 minus ln of going towards 0, right? It is going towards 0, and since 0 is the lower limit, so we will approach 0 from the right hand side. So going towards 0 from the right hand side, ln of 1 is already 0 minus going towards 0. So if you look at the graph of the ln x, when we are approaching towards 0 from the right side, the graph goes towards minus infinity. So this is minus of minus infinity, that will become plus infinity. So again we say it diverges. So what is the result in this case? We are getting for the p less than 1 it converges, and for the p greater than or equal to 1 it diverges. And in the first case it was less than equal to 1 diverges, and in the second case greater than or equal to 1 diverges. But the common solution we can say we are looking for where both of them diverges. So common solution we can say when both are equal to 1, when p is equal to 1, both diverges. So the option number B is going to be the correct answer. For p is equal to 1, both diverges. So I hope you have understood this concept of the improper integral, how to solve the improper integral. So if you like this video, please subscribe to the channel, and thank you for watching this.